Okay, welcome to the video about compound growth. Let's talk first about what is compound growth. Compound growth is when you have a situation that's growing by a percent. So growing by a percent. Okay, so a percent that is getting added back in to the original amount. So that percent is being added. It's being added back into the original amount. Two examples off the top of my head. One is when we have a bank account and we are earning a percent interest. So maybe a savings account or a certificate of deposit, and that interest is being added back into the amount that we have in the bank account. Nothing's being taken out. The other common example is when we have population growth. You know, maybe they say the town of Fairfax is growing by 2% a year. Well, people aren't leaving, we're just adding that 2% on each year. Okay. How do we write the rules for compound growth? We want to write an x equals now and a y equals rule. And since this is just another form of exponential growth, we're still going to use the regular exponential rules. X equals now times b starting at a. So a is our starting amount, b is our growth rate, or y equals a times b to the x power. So again, a is the starting amount, or sometimes we call it the initial value, and b is our growth rate. Now, the important thing is that we're often given the percent of increase. Say if it's a population, I just used the example that maybe the Fairfax population is growing by 2% per year. When we use that percent, it's going to go into our growth rate, into our B, but we need to do a couple of things to it first. The first thing we need to do is to change that percent to a decimal. So you're going to move the decimal point over 2 places, so it's going to be 0.02 as a decimal. The second thing we need to do is we're going to need to put a 1 in front, so it's going to become 1.02. Now the reason for that is if we just put 0.02 in for our b value, we don't have something that's greater than 1, so our data is actually going to decay, it's going to decrease, because we don't just want 2% left of our data each time, we want to add that 2% in. So by putting the 1 in front, it's like saying we want to put 102%. We want our 100% of our initial data, or our initial value, population, plus 2% being added in more. So we have 102%. So by adding the 1 in front, it allows us to add the percent onto the original amount. So for you, that means you just need to remember to make sure you have the 1 when you change a percent to the decimal. You have that adding that 1 in there, so it gets added onto the original amount. Let's look at a couple examples. Example 1, you win the lottery. Yay, the prize money is $10,000. It will go into a bank account paying 8% per year. You can access the money when you're 21 years old. How much money will you have then? Well, to start out, let's put this into an equation. We have next equals now. 8% is going to be, I'll write it over here, 8% is going to become 0.08. And then remember, we're going to add that 1 in front. So we're going to do times 1.08, starting at $10,000. Or if we go to our y equals $10,000 times 1.08 to the x power. Now, if we are, let's say we're currently 15 years old, and we want to know how much money it's going to be when we're 21 years old. If this is our 0th year, we have 16, 17, 18, 19, 20, and 21. So that's 1, 2, 3, 4, 5. We want our 6th year. Okay, so we're going to go to our SmartView calculator, and I'm going to go to my y equals, and I'm going to put in 10,000 parentheses 1.08 to the x power. Oops, it didn't get the exponent there. Raised to the x power. And then I'm going to go look at my table, and I want to know, so if we go to the top of the table, there's our 10,000, and it's growing by 8%, so there's another 800. So 6 years later, if I'm 15 now, 6 years later is when I'm 21, and it looks like I have $15,869. So 21 years later, excuse me, 6 years later, oops, what did we say we had? 15,869. $869. Great. So the important thing to remember here is this 1.08 as part of our growth rate, and that make whatever you're at now the 0, and then we'll just add on the number of years to get to the year that we need. One more example. The population of Podunk, North Dakota is 2,500 people in the year 2010. If the population is growing 0.2%, so that's really small, 0.2%, what will the population be in the year 2020? Well, we can clearly see that that's going to be 10 years later. So if the year 2010 is going to be year zero, then the year 2020 is going to be 10 years later. Let's do a couple of equations. Next equals now times. Now, if we take 0.2%, I still need to move my decimal over 2 places. So it's going to be 0.002 in this case. And then I'm going to add that 1 in front. So it's going to be times 1.002, starting at 2,500 people, or y equals 2,500 times 1.002 raised to the x power. So we said 10 years later is the year 2020. Let's go to the y equals and in our calculator and see if we can work this out. So in my y equals, I'm going to clear this. We said 2,500 times 1.002 raised to the x power. And let's go look at the graph, the table I mean. So 10 years later, this is pretty small growth. Here's 10 years later, we have 2,550 people. And that 0.5 can't have 0.5 of a person, so we'll round up since it's 5 or above. So 2,551 people 10 years later. So we have 2,551 people 10 years later. Just to give you another little bit of notation, sometimes rather than using our traditional y equals a times b to the x power, people like to use a format, the population is equal to the initial population, p sub o, times the rate to the number of years t. So this is just another way of showing the same thing. We're using t for time instead of x, r for the rate, the population growth rate, and p sub o is a way to write the initial population. I just wanted to show you that, so if you ever saw it, you wouldn't be confused. You may want to go ahead and add the compound growth to your vocab section. And so if you want to say that it's growth where a percent is being added back to an ORIG original amount. Okay, so go ahead and put this in your vocab on a blue sheet. Compound growth, growth where a percent is being added back to an original amount. And maybe you just want to remind yourself, put a 1 in front of the decimal. And if we use the example, 2% growth becomes 0.02 as a decimal, which becomes 1.02 in our equation. Okay, see you in class.